Hi guys, my name is Suraj Prasad. I'm a BTech graduate from IT Patna with Electrical Engineering. And today we'll be solving the paper of JEE Advanced 2016 chemistry questions. I wish first of all the best to all the guys who have attempted JEE Advanced 2016. Okay, they must be waiting eagerly for their results also. So all the best to them. And with that, I want others who are viewing this video to pick up those basic concepts and the areas which JEE Advanced paper demands nowadays, so that if you are good at it, it will be very helpful for you in getting the confidence. Okay, and also when you'll be solving the question, you'll be pretty sure of it that yeah, I can now solve any question with any topic if it comes. So here is the first question. There is a multiple choice question with one correct answer only. It came this year in JEE 2016 Advanced. It says it has shown 4 graphs, right? And says P is my probability of finding the 1s electron of hydrogen atom in a spherical shell of very small thickness dr, some distance r from the nucleus. And the volume is 4 pi square dr. Okay, so what could be the qualitative sketch, right? So you guys know that if I have let's say 1s, if I have 1s, so the L value is 0, so my nodes which will be getting formed will be n minus 1 only, and it is 1, so there will be no nodes, not the radial nodes I'm talking about. Okay, and also here the angular nodes, if we'll talk about, that will be also 0. So if I'm looking for the probability, if I'm looking for the probability of this 1s is a spherical in nature, right? 1s, the shape is spherical in nature. Then the graph of this probability density, if I'm talking about, it should be like if I plot 4 pi r square to r square versus my r. Okay, this will be, should come like this. It should go at maxima, then again if I increase the distance, I'll be having no electrons, right? I'll be having no electrons. So that is why the correct answer for this has to be your B part. Correct, your correct answer has to be your B part. So we'll say that yes, the option B will be correct over here. And the option B will be correct over here for this question. If I look for next question, 1 mole of an ideal gas at 300 Kelvin in a thermal contact with surroundings, it expands isothermally from 1 liter to 2 liter against a constant pressure of this much, 3 atmospheric pressure. So what is the entropy of surroundings in joules per Kelvin? Also you've been given that you can use your 1 liter atmosphere in terms of the joule energy, that is 101.3 joules. Now guys, you know that if my system is losing something, it must be gaining by your surroundings, or vice versa. If suppose my surroundings is losing something, okay, then I would say that my system is gaining something. So obviously if these kind of situation comes, then you have to keep in mind that my delta S surroundings, if I am talking about, okay, which I can also write it as Q surroundings by T, correct? But this Q surrounding by T is actually minus of Q of system by T. And this is what I was telling you, which if it is saying an isothermal process, right? So the first pickup trick should be the isothermal point. At your isothermal process, your delta U is 0. So obviously your Q will be equal to minus W. So if I'm saying minus Q of system, by T, so that is actually equal to my plus of work of system by T, correct? And what is the that work? That is your P external into V2 minus V1. So basically my del S surroundings will be minus of that. So that is your minus P external was 3 atmosphere multiplied by V2 minus V1 by temperature given is 300 Kelvin, and this will come out in liter and atmosphere, right? So I'll have to multiply by 101.3 given in the question to get my answer in joules. So, and this will be equal to minus 1.013 joule per Kelvin. So you can see that out of these four options, my option C is correct, right? My option C is correct, and hence I can say that C is the correct answer for this question. Let's move on to the next question. The increasing order of atomic radii of the group 13 elements will be what? Now this question demands your grasp regarding the topic of, let's say, effective nuclear charge, then shielding effect, those all stuffs, because many of the students, they got confused. They just thought that if I move down a group my size will increase, right? But there's a exception case of your aluminium and gallium, guys. Okay, if you look for, then your radius of aluminium, okay, it comes out to be more than your radius of gallium. I'll tell you also the values. Okay, these values are 143 picometer and 135 picometer, although a very less change, but your aluminium is having more size than your gallium. And why does it happen? It happens due to poor shielding of nuclear charge by your 3D electrons. So in your gallium, if I'm talking about, which is having 3D electrons present over there, so the shielding effect there is quite poor, and that is why my effective nuclear charge increases a bit and the size decreases. Okay, and the size decreases. So that is why if I, and the other things are quite regular with the trends. So if I go via the method, I'll get my gallium is least, okay, then my aluminium, then comes my indium, and then comes my TL thallium. So looking at this, your option which is matching over here, you can easily see it's my B option correct, right? So my B will be the correct answer for this question. Shielding effect you have to take care of. Now next question says, on complete hydrogenation by natural rubber, it produces what? So this question came from the chapter of polymers, right? And you know that if I have natural rubber, that is your isoprene. So if I pass my isoprene and if I do the hydrogenation of it, right? Say if I have that natural rubber isoprene with me and I'm doing the hydrogenation of it, then what will happen? I will get something like this. Then it will again repeating like this way. So this is the place where my the double bonds have been reduced, okay, to my alkanes. So this compound when I will form in a polymeric way, okay, it's actually my ethylene molecule over here, okay, plus my propylene molecule which is coming into the picture. So they are getting polymerized, and that is why, means this is actually what this is your CH2 okay, and this is your CH is your CH2 double bond CH3. So they are getting polymerized, okay, on this ground, and that is why my answer which I should get is ethylene propylene copolymer. Ethylene propylene copolymer, and hence my A will be the correct answer. Hence my A will be the correct answer. Let's move on to the next question. Among these groups, you have to tell me total number of paramagnetic species, guys. So as you all know, if I am dealing with the paramagnetic stuff, paramagnetic species, then I am basically moreover concerned with the unpaired electrons, right? Unpaired electrons. How many unpaired electrons they all have? If they have unpaired electrons, then I will say yes, it is a paramagnetic. If they don't have, then it is a diamagnetic. So if I one by one I'll be writing its the compounds and their electronic configuration in that particular molecule. So NiCO4, if I have, CO is a neutral ligand, right? So there is no charge involved over here. So I'll be getting normal oxidation state of nickel, which is your 3d10. I'll get, right? I'll get the 3d10. But see, and why I'm getting 3d10? Because CO, although it is a neutral ligand, but it is a strong ligand, right? So it will make it to get pair up, alright? So this is having 0 unpaired electrons, and that is why it is a paramagnetic species, because CO being here is a very strong ligand. If I talk for NiCl4, 2 negative. So here in this case you can see that 2 negative charge is present over here. If I take out the oxidation state of Ni, it will come as x minus 4 is equal to minus 2, so x will be equal to your plus 2. So Ni2 plus is there, which means I'll be having the 3d8 state, right? And here my electrons which are present over here, they are like Cl being weak ligand, the Cl being weak ligand, so they cannot be pair up. I cannot pair up those electrons, and that is why if I will show you like 1 2 3 4 5, so 1 2 3 4 5 6 7 and 8, these two will not get paired up because of your lower strength of the ligand, right? Means it is very weak ligand, and that is why I will say that there are 2 electrons which are unpaired over here. So yeah, it is my one of the paramagnetic species, guys. Okay, this is the paramagnetic species. Now let's move on for the next, which is my CONH3 whole 4 Cl2 Cl. Okay. So if I talk of this again, if you will calculate your you have to first calculate your oxidation state, right? And when you will calculate, you will find that the configuration which cobalt is getting over here, that is your 3d6. But again, your NH3 ammonia which is present over here, it is a strong ligand, right? You cannot ignore it. So the electrons will be paired up, and hence there will be 0 unpaired electron, guys. There will be 0 unpaired electrons. If I look for the next molecule, which is my Na3 CuF6, this is the molecule which I have. So the cobalt here again, it is 3d6. But fluorine being here weak ligand will not pair up, guys. Okay, they will not pair up, and this time there will be 4 unpaired electrons present over here. So yeah, this is also a paramagnetic species. I get my second paramagnetic species. So this question is only demanding your knowledge of the unpaired electrons present in that particular molecule. Okay, we have one more, I guess. Yeah, we have two more, Na2O2 and CSO2 also. Okay, so if I draw for Na2O2, this is your simple O2 negative, O2 2 negative, right? And hence it will be like 0 unpaired electrons. There is no unpaired electrons over here. If I talk for CSO2, this is a superoxide. So here my oxygen is having my O2 minus 1 charge, and so here you'll be having one unpaired electron. You can also tally with the MOT theory. So this will be my third paramagnetic species. So you can see that 3 are coming as paramagnetic compound. So my B option should be correct for here. Okay, my B option will be correct here. Let's move on for the next question. A plot of number of neutrons and against the number of protons. Okay, N by P plot of stable nuclei exhibits upward deviation from reality for the atomic number which is having Z, the atomic number greater than 20. Okay, so for unstable nucleus having N by P ratio less than 1, the possible modes of decay are what? Fine. So if I talk for the neutron to the proton ratio, right, and I have to make it less than 1, so when this will happen? This will happen if I'm having any decay of protons, right? Like for example, if I say my if I'm decaying a beta particle, so this will be left over with your beta decay, right? Not the, if I'm saying beta decay, then it will be the minus 1 B0. No, sorry. So there will be no beta decay. There will be positron emission then. Okay, there will be positron emission which will be giving me the neutron kind of stuff, right, which I require, which is demanded in the question. So there will be B plus decay. There will be B plus decay, and hence I can get like this. B plus decay will be getting like this. So this is one way in which my N by P ratio can be my less than 1. Then another way is when I will be adding some electrons, right, or which is mentioned over here as K electron capture, right. So let's say if I have this and I have captured the electron, K electron is like this way. Okay, so this will be giving me this stuff. So again you can see that I'm getting the required answer. So for this, my B and D, they both will be the correct answer. So this was actually your multiple choice question, guys. This was your multiple choice question. So this thing demands your knowledge regarding the particles, right, like beta, the positron particle, beta plus, beta negative, neutron. So you should have a good idea of all these stuffs. So for this question, my B and D will be the correct answer. B and D will be the correct answer. Let's move on to the next question. The correct statements of the following reaction sequence: cumene, then I'm getting P, okay, then I'm passing it to CHCl3, QR. Fine. So cumene, all of you know, right? Cumene is your isopropyl benzene. Cumene is simple isopropyl benzene. So if I have isopropyl benzene and I'm oxidizing it, what should I get? If I have isopropyl benzene and I will oxidize, what should I get? I should simply get a phenol over there, right? Like if I draw over here, this is my isopropyl benzene, right? If I'm oxidizing it and passing with this media, I'll be getting my phenol. So this is my P, which in the question it's been asked. Then next, if I am passing CHCl3 NaOH, so you should know that this is your Riemann-Tiemann reaction, guys, right? This is your Riemann-Tiemann reaction in which you treat phenol with CHCl3 and NaOH. What is formed? You get your salicylaldehyde, right? You get your salicylaldehyde, which will look like this. So this is the major thing. So this is your Q. Also, it can combine, it can give a product like this way at the para position. So this must be your R. This must be your R. Next thing, Q, it is treating with NaOH and PHCH2Br. Okay, so Q, which was my salicylaldehyde. Okay, let's now treat it with that reagents. So what will happen first? First my OH will be replaced by ONA, and then the Na will be replaced by this group, which is written over here. Okay, PHCH2. So finally I'll get something like this. Okay, this is what I'll get, and this is your S. This was your Q, right? Now let's so now we have all the products. So let's see the options. A is saying R is steam volatile. R, if I look at, this will be not steam volatile. Instead my Q will be steam volatile because there is a possibility of hydrogen bonding over here, right? So my A option is not correct. A is not correct. If I look for B, B is saying Q gives dark violet coloration with 1% aqueous FeCl3. Let's look for Q. So Q is your salicylaldehyde, right? Now guys, you must know that your alcohols, they give violet colors. They give violet colors if I pass the FeCl3 solution to it, correct? And in the salicylaldehyde you have a alcoholic group present over there. So obviously you'll get the violet coloration with the 1% aqueous FeCl3 solution. So this is our test of alcohol also, right? So my B is the correct answer. Let's move on to C, because this is also multiple choice answer. So C is saying S gives white precipitate with 2,4-DNP. So S, if I talk about, this is my S. If I treat with 2,4-DNP, so with whom we treat the 2,4-DNP? With all the with all the carbonyl groups, right? So which can give me NZ kind of structure. NH2 NH2Z, if I treat, then they'll give me NZ structure. So it's not only S. even your Q and R will also give you the they will also give the positive test of 2,4-DNP. So my C is also correct. Okay, then move on to last. S gives dark coloration with aqueous FeCl3. See guys, in S, if you will see, there is no phenol. Okay, here there is ROR type of stuff, ether. Here you have aldehyde, so there is no phenolic group present over here, so S cannot give your the white coloration property, which is actually the property of alcohols. So for this, the correct answer has to be your B and C only. Okay, your B and C will be the correct answer for this. And next, I hope this is clear. Some reaction will be very famous name reaction. Some you have to apply your mind, so you have to do it like that way. Next, next is asked positive tolerance test is observed for. Now you guys better know that if I'm looking for the tolerance test, then they are basically given by my aldehydes or the terminal alkynes or the CHOH group. So you have to just search for it. If I talk of A, which looks like this, so in this compound it's simple, right? This is the aldehyde group present over here. So obviously if I treat with the tolerance reagent, then I'll get my silver mirror, right? So this will show aldehyde group. Even in the B case, which is benzaldehyde, right? So it's again an aldehyde group. This will get oxidized, and I'll again get my silver mirror if I pass tolerance reagent to it. If I look for the C option is something like this. So this is a CHOH stuff, right? This can also get oxidized, and hence this can give me the tolerance test, positive tolerance test. If I look for the D option, sorry, if I look for this option, then there is no probability of having the positive tolerance test, because this is a keto group over here. This is not a aldehyde group or the CHOH group or any terminal alkyne. So the correct answer for this question will be your A, B and C. Let's move on for the next question. The products of the following reactions, NH2, then acetic anhydride and pyridine, KBRO3 HBr, then H3O plus heat, then NaNO2HCl. So wherever you find NaNO2HCl, the idea which should come in your mind is that there will be some formation of diazonium chloride salt, right? Diazonium salt, and then CuHBr. So bromination must be happening the end. So let's solve this question one by one, step by step, so that it will be clear to you that what should get formed, what should not get formed. Okay. So this is also is or are, so that means there can be a probability of multiple answers. So let's see one by one. The first case, it's given NH2, aniline is given, and I'm passing it to the acetic anhydride, okay, which I'll let's say represent like this way in pyridine. So what will happen? This will be acting like protecting that group. It will be combining with it, NHAC, right? Then as the group is protected, now if I add the KBRO3 by HBr, now this thing cannot combine with the NH2 stuff, right? So it will search for bromination, and obviously it is electrophilic bromination. It will search the ortho and para position, and for this my para position will be more stable, so I'll get something like this, okay, after passing the KBRO3. Then what is written, it's written that I am passing it to the acidic solution, acidic media, and heating it. So that simply means that I'll again get my NH2 back into the picture, and with a bromine over here. Okay, with a bromine over here. And then it's quite simple for you guys. NaNO2 plus HCl, as I told you, you have to do what? It will form the N2 plus Cl negative, the diazonium salt, right? And at the para position it is having bromine over here. And this reaction happens at 273 to 278 Kelvin. Okay. Then last step is your copper HBr. So it's simple, the bromination step, and that will be happening on the diazonium salt. So it's your Br, so I'll get this product right at the end. So if you ask from the options, then I think only B is the product which we are getting at any stage, right? Others are different. So this is so for this multiple choice answer, only one answer will be correct. Okay, so sometimes it happens that even the question is multiple choice, so that is why it is always written one or more answer correct. Okay, so one can also be correct. So only your B answer will be correct over here for this question. Now let's move on for the next question.